advancing down the valley.
All right, keep low and watch for infantry.
January 1943. The bitter wind cuts across a frozen French countryside. Snow drifts bury shattered trees along the steel arteries of the Allied supply lines. The rumble of German tanks echoes through narrow valleys, a reminder that every hour of delay could tip the balance of the front. Amid the chaos, a small American engineering unit works with remarkable precision. Sparks fly as track panels are welded back together. Planks are hauled, and heavy cranes lift damaged rails into place. Men move with practiced efficiency, their breath visible in the icy air, fingers numb but unyielding. Nearby, a group of German officers crouch atop a ridge, binoculars in hand, eyes widening in disbelief. How can these Americans rebuild in mere hours what would take German units days? The trains return to life, wheels clattering over freshly repaired tracks, delivering fuel, ammunition, and reinforcements to the front. The battlefield shifts silently beneath the Germans' astonished gaze. In a war of steel and speed, this moment would leave an impression on those who saw it. Logistics could be as decisive as bullets. By 1941, the world had descended into a war unlike any before. Across Europe, Germany had advanced with terrifying speed, its blitzkrieg tactics combining tanks, aircraft, and infantry to overwhelm opponents in days. The mechanized army depended on one critical vulnerability: the supply line. Without fuel, ammunition, and reinforcements, even the most formidable panzers would grind to a halt. For the Allies, this created both peril and opportunity. Railroads had become the lifeblood of modern warfare. They carried tens of thousands of tons of materials across hundreds of miles, linking factories in the heart of the United States and Britain to the front lines in France, North Africa, and later, Italy. A single destroyed track or sabotaged bridge could delay an operation for days. Every day lost meant fewer shells in the guns, fewer fuel drums for vehicles, fewer rations for soldiers. The United States entered the war in December 1941, following Pearl Harbor, but its industrial engines were already running at full capacity. Factories churned out tanks, aircraft, and trucks at rates the world had never seen. Alongside production, military engineers trained in new methods of rapid construction and repair. Prefabricated track panels, modular bridge sections, and specialized repair vehicles were designed to minimize downtime. Every hour counted. German intelligence had underestimated this aspect of American warfare. Reports from spies and aerial reconnaissance noted the sheer volume of equipment crossing the Atlantic, but few predicted the speed with which it could be mobilized once it arrived. While the Wehrmacht focused on frontline tactics and armored thrusts, American logistics units quietly demonstrated that the war could be won not just with firepower, but with speed and organization. Across North Africa, Allied forces faced harsh deserts and unreliable infrastructure. Supply lines stretched hundreds of miles over terrain that swallowed trucks and convoys. When tracks were bombed or destroyed by retreating Axis forces, traditional repair methods could take days. American engineering battalions introduced innovations that changed this calculus. Steel panels could be carried on flatbed trucks. Cranes lifted heavy rails into place in hours, and night operations often restored entire segments before the enemy could react. By early 1942, these innovations were being applied on the European front. In the winter months, engineers braved snow and ice, repairing rail lines under artillery fire and air raids. Their work was precise, almost surgical, as sections of track were replaced, leveled, and secured to withstand the weight of loaded trains. For the Germans, observing from afar, it seemed almost unbelievable. Units that should have slowed the Allied advance merely kept pace, reinforcing front-line positions with remarkable efficiency. The speed of repair had tactical consequences. Artillery units could receive ammunition without delay. Infantry divisions were reinforced before German units could consolidate gains. Tanks, dependent on fuel and maintenance, could continue their operations, denying the Wehrmacht the opportunity to exploit temporary weaknesses. In essence, every repaired track extended the reach of the Allied army and compressed the time available for German commanders to respond. But it was not just a matter of machinery and manpower. Leadership played a decisive role. American commanders understood that logistics was not a background function. It was a force multiplier. Plans were drawn meticulously, contingencies prepared, and specialized units deployed with the express purpose of restoring mobility. Each engineer, welder, and driver became a crucial node in a vast operational network, moving supplies faster than enemy reconnaissance could calculate. And while the Germans focused on tanks and infantry, they could not ignore what they saw unfolding along the horizon. German officers, accustomed to slower, methodical repair processes, were shocked by the speed, coordination, and sheer resilience of these units. Reports from the front frequently mentioned the miraculous restoration of rail lines, the almost preternatural efficiency with which American engineers operated. For a military culture built on precision and control, this presented both admiration and frustration. The stage was set for a confrontation not just of armies, but of philosophies: brute force versus organizational excellence, rapid repair versus slow attrition, improvisation versus industrial planning. What the Germans did not yet fully grasp was that the ability to restore a track in hours rather than days could, in the coming campaigns, decide the outcome of battles. And for the Americans, each repaired mile of steel was a statement. The war could be won not only by bullets, but by ingenuity and relentless speed. The Germans would witness this firsthand in the months ahead, as their plans collided with a logistical machine that moved faster than they could anticipate. The astonishment of officers peering through binoculars from snowy ridges was only the beginning. In North Africa, 1942, the desert became both battlefield and proving ground. Rommel's Afrika Korps moved with precision across open sands, relying on stretched supply lines that were vulnerable to Allied disruption. American engineers, working alongside British units, faced the monumental task of keeping rail and road networks intact. Tracks destroyed by retreating Axis forces were replaced in record time. Prefabricated sections, designed to snap into place, allowed entire rail lines to be operational within hours. Soldiers often watched in awe as cranes lifted twisted steel while dust swirled in the wind, a reminder that logistics could move faster than any tank. Across the Atlantic in Europe, winter brought its own challenges. Bombed rail yards in France threatened to stall Allied offensives. Cities like Cherbourg, Caen, and Antwerp were critical hubs, but they lay in ruins from aerial bombardments. Here, American repair units showcased a blend of ingenuity and relentless determination. Teams worked in rotating shifts, often under German artillery fire, welding, bolting, and leveling track while the wind howled and snow blinded their vision. Night operations became a strategic advantage. Germans rarely anticipated repairs could be completed under darkness, yet by morning, supply trains rolled steadily forward. Engineers were not alone in this effort. Truck convoys transported spare rails and heavy machinery, while infantry units secured repair zones. Coordination was meticulous. Every man had a task, every tool a purpose. Observers noted that these units operated less like conventional soldiers and more like a living, breathing factory, bringing industry to the front lines. For the Germans, who had grown accustomed to destruction creating delays, the sight was unsettling. Officers recorded in diaries and intelligence reports their disbelief. How could a single nation repair miles of rail faster than an entire corps of engineers might expect? In Italy, 1943, mountainous terrain added another layer of complexity. Rail lines hugged cliffs, crossed bridges, and tunneled through jagged rock. Bomb sections threatened to isolate divisions and halt advances. Yet, American engineers adapted. They constructed temporary trestles, rerouted tracks, and used modular bridge segments to reconnect supply lines in days, sometimes hours. Soldiers recalled the almost frantic pace of work, yet everything was precise. No section too long, no connection poorly aligned. Efficiency under pressure became a hallmark of the U.S. Army Corps of Engineers. The human element cannot be understated. For every German officer observing these feats, there were men on the ground. Young Americans in wool coats, grease-stained and exhausted, working methodically to defy the limitations of war. Letters sent home describe long nights in freezing temperatures, the constant roar of artillery in the distance, and the sense of purpose that came from knowing their labor directly saved lives. For engineers, every repair mile of track meant more fuel for tanks, more shells for guns, more food for soldiers at the front. Their work was invisible to most, yet it carried the weight of entire operations. Reports from the German side emphasized the shock experienced when attempting to disrupt Allied logistics. Sabotage, bombing, and raids slowed progress only momentarily. Within hours, tracks were repaired and convoys resumed. In several accounts, German officers admitted that the American speed bordered on miraculous, noting that what they had assumed would take days or even weeks was undone in mere hours. These assessments were not exaggerations. Reconnaissance photographs, intercepted communications, and post-war memoirs corroborate the efficiency of these engineering operations. By late 1943, the pattern was clear. Wherever the Germans anticipated delays and sought to exploit broken lines, American engineers moved faster than expected. Logistics became a weapon in itself, a silent force shaping the battlefield. The speed and precision of track repair not only enabled offensive operations, but also preserved morale, showing soldiers that no setback was permanent, no disruption insurmountable. The Germans' astonishment foreshadowed a critical truth. In modern mechanized warfare, victory was not determined solely by tanks or bullets, but by the invisible hands that kept the wheels turning. The stage was now set for the next phase, the confrontation of perspectives, where human, tactical, and technological angles would reveal just how decisive this logistical efficiency truly was. On the frozen ridges overlooking bombed-out rail yards, German officers recorded their disbelief. Binoculars in hand, they watched a small group of American engineers move with relentless purpose. Men with soot-stained faces lifted rails heavier than themselves, coordinated in near-perfect unison, while the air hummed with the clang of hammers and the roar of welding torches. For the officers, trained to measure military strength in tanks, guns, and numbers of soldiers, this display was both alien and unnerving. Behind the efficiency lay long hours, cold nights, and exhaustion. Letters from engineers reveal aching muscles and frozen fingers, yet an unwavering focus. Their comrades in the field relied on them. Every repaired mile meant that artillery could fire again, that infantry could advance, that fuel would reach waiting tanks. Soldiers describe a rhythm almost musical in its precision. Rails dropped into place, bolts fastened, ties adjusted, as if the battlefield itself demanded a symphony of labor. This human determination under pressure became a defining feature of Allied operations, a quiet heroism largely invisible to history, yet pivotal in outcomes. The rapid repair of rail lines reshaped battlefield strategy. In North Africa, when Rommel's tanks threatened to cut off British and American supply routes, the ability of engineers to restore tracks within hours altered the calculus of pursuit. Where German commanders anticipated exploiting destruction to isolate divisions, they instead found well-supplied fronts ready for counterattacks. Every repaired section of track extended operational reach. Artillery units could reposition without delay, reinforcements arrived just as planned, and fuel depots remained stocked. Commanders began to integrate this capability into planning. Raids and airstrikes on rail lines became less decisive, as the Germans learned that temporary disruption was no longer permanent. In essence, the battlefield expanded, not through territory gained, but through the accelerated mobility of Allied forces. Speed became a tactical weapon, and engineers were its wielders. American ingenuity drove this unprecedented pace. Prefabricated track panels, modular bridges, and portable cranes turned the repair process from a laborious task into a rapid operation. Engineers could carry panels on trucks directly to destroyed segments, align them in hours, and weld them under harsh conditions. Specialized vehicles, some designed specifically to lift and place rails, moved like mechanized assistants, minimizing manual labor and maximizing precision. In Italy, mountainous terrain posed unique challenges. Engineers deployed modular trestles and temporary bridges, often under fire, enabling entire supply lines to reopen in record time. Rail lines that would have required days of excavation and construction were restored in hours. The Germans, accustomed to slower, methodical repair processes, recorded these innovations with astonishment. Reports describe machines and men moving as one, faster than the eye could follow, emphasizing that the combination of human skill and technological innovation created a force multiplier unlike anything seen before. Behind the scenes of every rapidly repaired rail line stood meticulous planning and decisive leadership. American commanders understood that logistics was not a mere support function. It was a strategic weapon. Orders were drawn with precision, assigning repair units to sectors, synchronizing with artillery, infantry, and armored divisions. Engineers operated in rotating shifts, ensuring continuous work through day and night. In one notable instance near Cannes, France, leadership dictated a dual approach. While some teams replaced bombed rails directly, others prepared bypass tracks and temporary bridges. This redundancy meant that even under artillery fire, supply lines remained functional. Commanders encouraged initiative among junior officers, empowering them to make real-time decisions on how best to restore mobility. It was this decentralized yet coordinated approach that allowed rapid repairs under the most extreme conditions. Leadership transformed technical skill into operational advantage, turning the unseen labor of engineers into decisive outcomes on the battlefield. German intelligence and frontline officers were often stunned by what they observed. Reconnaissance reports, intercepted communications, and post-war memoirs all note a recurring theme. Americans could repair tracks at a speed that seemed impossible. For a military culture that measured efficiency by methodical planning and resource control, these feats were bewildering. Frontline German commanders frequently expected delays to disrupt Allied offensives. Bombed rail yards, destroyed bridges, and sabotaged lines were assumed to buy critical hours, even days. Yet, within a single day, trains resumed movement, ammunition arrived at the front, and tanks received fuel. Intelligence officers documented their astonishment, sometimes framing it as almost supernatural efficiency. While these observations were factual, they also carried a growing sense of unease. The Germans realized that even when they destroyed infrastructure, the Allies' engineering units could nullify the effect almost immediately. This perspective would influence German operational planning for the rest of the war, underscoring the strategic importance of mobility and repair in modern mechanized conflict. Rapid track repair carried psychological as well as physical consequences. For Allied troops, the sight of engineers restoring supply lines under fire was a tangible reassurance. No obstacle was insurmountable, no destruction permanent. Morale improved as artillery remained operational. Rations arrived consistently, and tanks moved without interruption. Soldiers knew that a well-coordinated logistical backbone existed behind them, silently securing every advance. Conversely, German soldiers and officers could not ignore the message sent by these feats. Reports repeatedly emphasize the astonishment and frustration generated by American efficiency. Propaganda within German ranks downplayed the effect of destroyed tracks, but in private accounts, officers admitted the psychological impact. The speed of repair challenged assumptions about the Allied army's limits, creating uncertainty and a subtle erosion of confidence. Rapid track repair, therefore, was more than a technical achievement. It became a moral factor, reinforcing Allied cohesion while sowing doubt among enemy ranks. June 6, 1944. Normandy. The beaches had been secured, but the success of the invasion depended on something far less visible than the guns and tanks rolling ashore: the railways. Bombed bridges and shattered tracks threatened to halt the flow of reinforcements and supplies. The Allies faced a precarious moment. Every hour of delay could allow German units to regroup and counterattack. American engineering battalions moved with a singular purpose. Using prefabricated track sections, cranes, and portable welding equipment, they rebuilt entire sections of the railway in a matter of hours. In the town of Corentin, where retreating German forces had destroyed the main line, engineers arrived at dawn. By mid-afternoon, tanks rolled over the newly laid tracks, ammunition trains followed, and frontline units were resupplied before nightfall. German officers, observing from the surrounding hills, recorded their astonishment. What they had expected to be a 2-day delay was neutralized in hours. This pattern repeated across Normandy. At Cherbourg, a critical port for resupply, Allied engineers faced destroyed docks and rail lines. Using modular trestles and rapid construction techniques, they restored connections to the hinterland within days. Fuel, artillery shells, and reinforcements flowed seamlessly. German intelligence noted the anomaly. Despite extensive sabotage, the Americans maintained operational momentum. Every repaired mile of track became a lifeline, keeping offensives alive and preventing the Wehrmacht from exploiting temporary disruptions. The effect was tactical and psychological. Infantry units, once limited by disrupted supply chains, advanced with confidence. Armored divisions moved swiftly along restored rails, achieving positions German commanders had assumed would be delayed by days. Reports from frontline observers described the near magical speed with which engineers worked. Rails replaced, bridges patched, and supply trains moving before the enemy could respond. This was not luck. It was the culmination of meticulous planning, technological innovation, and relentless human effort. In Italy, late 1943, mountainous terrain presented another test. The Allied advance from Salerno to Naples relied heavily on rail supply. German forces destroyed key lines, intending to slow the advance and buy time for defensive positions. Yet American engineers adapted rapidly, rerouting tracks, building temporary bridges, and deploying cranes to lift heavy rails over cliffs. Entire supply lines were restored in days, sometimes hours, ensuring that frontline divisions remained operational. German officers and reconnaissance units expressed disbelief, noting that where destruction was meant to stall the Allies, it had merely set the stage for continuous advance. Even in the harsh deserts of North Africa, the principle held. Rommel's forces had targeted supply depots and rail lines to isolate British and American divisions. Yet, American repair units, often working under fire, restored tracks with astonishing speed. Convoys carrying fuel and ammunition resumed operations almost immediately, preserving the tempo of Allied offensives and preventing Axis forces from exploiting gaps. It was during these operations that the human dimension became most visible. Engineers labored under artillery and air attacks, enduring freezing nights and scorching sun. Soldiers who passed through the rail yards often noted their precision and speed, comparing it to clockwork. Commanders relied on these feats, building operational plans around the certainty that destroyed tracks would be repaired before the next engagement. The psychological impact on German officers was profound. They faced a foe whose logistical efficiency nullified traditional advantages gained through sabotage or tactical disruption. By December 1943, reports from German intelligence highlighted a recurring observation. American engineers operated with a combination of speed, technology, and coordination that was unmatched in the war. The repaired tracks allowed the Allies to maintain offensive momentum, resupply artillery units, and reinforce weakened fronts without interruption. In essence, the ability to restore infrastructure rapidly became a decisive factor, one that German commanders had neither fully anticipated nor effectively countered. The stage was set for a series of engagements where these repairs would directly shape outcomes. The Germans had underestimated the force multiplier that rapid logistics provided, and the next phase of the war would make it undeniable. The front line now depended not just on firepower, but on the unseen yet relentless work of engineers, whose hands rebuilt the arteries of the battlefield faster than the enemy could sever them. January 1945. The Ardennes. The German counteroffensive, later known as the Battle of the Bulge, had initially pushed Allied forces back, creating chaos in the densely forested region. Supply lines were under extreme pressure. Roads were clogged with vehicles, many immobilized by ice and snow. German officers assumed that disrupted infrastructure would slow American reinforcements for days. Yet, behind the front lines, American engineering units were already at work, repairing railways and clearing obstacles with relentless efficiency. In Bastogne, where troops held an encircled perimeter, engineers reconstructed tracks that had been demolished by retreating forces. Within 24 hours, trains carrying artillery shells, rations, and medical supplies were rolling toward the beleaguered town. Tank and infantry divisions, once stalled by snow and destroyed roads, resumed movement. German intelligence noted their astonishment. Officers recorded in their war diaries that the Americans repair what we destroy faster than we can account for it. This realization reverberated throughout the German command. Disruption no longer guaranteed tactical advantage. Across Europe, similar scenarios unfolded. In the Netherlands, key rail junctions targeted by Luftwaffe raids were restored with precision. Temporary bridges replaced collapsed spans, and prefabricated track sections snapped into place as if the infrastructure had healed itself overnight. Engineers often worked under the threat of artillery and air attack, yet maintained a tempo that defied expectations. These rapid repairs allowed supply convoys to reach forward positions, sustain offensives, and maintain pressure on retreating German units. The technological edge was critical. Modular bridges, portable cranes, and prefabricated track panels enabled operations that would have been impossible using conventional methods. In some instances, entire sections of railway, previously considered irreparable, were rebuilt in less than a day. The combination of human endurance and technological innovation created a force multiplier that German planners could not overcome. Reports from the Wehrmacht repeatedly noted that the Americans' ability to restore mobility was unbelievable, with officers questioning whether such efficiency was even achievable under wartime conditions. One striking example occurred near Antwerp, Belgium, following heavy bombing of the city's rail yards in late 1944. Allied supply chains were threatened, and frontline divisions faced the possibility of halted operations. American engineers mobilized rapidly, using cranes and temporary trestles to bypass destroyed sections. Within 48 hours, trains carrying fuel, artillery, and reinforcements moved into position, preventing a potential collapse of the offensive. German reconnaissance units observed the restored lines and reported back, expressing a mixture of disbelief and frustration. Our efforts to sever their supply are undone in hours. These moments highlighted a new reality of modern mechanized warfare. The speed at which supply lines could be restored became as decisive as the strength of frontline units. German officers, who had relied on delayed repairs to buy critical time, found that every attempt to disrupt the Allies was neutralized almost immediately. What they had assumed would create strategic advantage instead became a testament to American operational superiority. The human dimension continued to shine through in these high-stakes scenarios. Engineers worked tirelessly, often in freezing temperatures or under fire, demonstrating discipline, coordination, and ingenuity. Soldiers in the field recognized their importance, referring to them as the invisible army, whose labor ensured that tanks moved, artillery fired, and rations arrived on time. The combination of morale, precision, and speed transformed engineers into a pivotal component of the war effort, making them central to operational success rather than ancillary support. By the end of January 1945, the implications were undeniable. In multiple theaters, Normandy, Italy, North Africa, and the Ardennes, the ability to repair tracks rapidly had altered the course of operations. German officers could no longer assume that destruction of infrastructure equated to delayed enemy movements. American logistical efficiency had become a strategic weapon, enabling continuous offensives and sustained supply under conditions that would have previously paralyzed an army. The astonishment of German officers, recorded in diaries, intelligence reports, and post-war memoirs, captured the essence of this turning point. The war, they realized, was increasingly defined not only by tanks and artillery, but by the unseen hands of engineers restoring the arteries of battle. In every engagement, from frozen forests to bombed cities, the restored tracks symbolized speed, innovation, and the relentless momentum of Allied forces. As German forces struggled to adapt, the stage was set for the aftermath. The consequences of rapid American track repair on the broader conflict, on strategy, and on morale. The battlefield had shifted, and the implications would resonate well beyond the repaired rails, defining the operational and psychological landscape of late-war Europe. The impact of rapid American track repair became clear in the weeks and months following key battles. Frontline units that might have stalled due to destroyed infrastructure instead pressed forward with continuity and precision. In Normandy, the restored rail lines enabled the delivery of artillery shells, fuel, and rations at rates the Germans could scarcely match. Commanders observed that attacks planned to exploit supply delays were rendered ineffective, leaving German units increasingly reactive rather than proactive. At Cherbourg, the rapid restoration of port connections allowed the Allies to stockpile supplies for the summer offensive. Trains moved steadily, day and night, carrying not only ammunition and fuel, but also reinforcements for infantry and armored divisions. The logistical backbone created by American engineers meant that divisions could maintain operational momentum without fear of isolation. German intelligence acknowledged the anomaly, describing the restored railways as a miraculous network that defied conventional expectations of war. The psychological effect on German forces was equally significant. Officers who had witnessed the speed of repairs reported feelings of frustration and incredulity. In personal diaries and post-battle reports, phrases such as beyond belief and mechanized miracle recur, emphasizing that these were not isolated incidents, but a consistent feature of American operations. The inability to disrupt Allied supply lines undermined confidence, leaving commanders questioning the reliability of their traditional tactics. North Africa and Italy reflected similar patterns. Supply lines that had been deliberately targeted and destroyed were repaired with astonishing speed, allowing offensives to continue with minimal interruption. Engineers often worked under fire, yet maintained the tempo necessary to ensure frontline units received critical supplies on schedule. Artillery units remained operational, infantry advances were sustained, and armored divisions continued their maneuvers. In each case, rapid repair prevented temporary tactical gains from becoming strategic advantages for the Germans. The operational consequences extended beyond immediate battles. With reliable logistics, Allied commanders could plan multi-pronged offensives, knowing that disrupted lines would be restored in hours, not days. This ability to maintain a continuous supply flow increased operational flexibility and allowed forces to concentrate firepower at decisive points. German forces, by contrast, were forced into defensive postures more frequently, unable to exploit the temporary chaos they sought to create. From a broader strategic perspective, the efficiency of track repair reinforced the principle that logistics could dictate the tempo of war. Supply and mobility became intertwined with operational success, shifting the balance in favor of the Allies. German planners, confronted by this new reality, had to reconsider the effectiveness of sabotage, bombing, and destruction of infrastructure as tools of war. Every repaired rail line represented not just restored mobility, but the neutralization of German strategic intent. The human stories intertwined with these operational outcomes were striking. Soldiers on the front lines frequently expressed awe at the speed with which destroyed infrastructure was restored. American engineers, often working in extreme conditions, snow, ice, mud, and under enemy fire, were described as indispensable and invisible heroes in operational reports. Their labor ensured that divisions remained supplied. Offensives continued uninterrupted, and the pace of war remained firmly in Allied hands. In essence, the aftermath of these rapid repairs was twofold: tactical and psychological. German plans to delay Allied operations repeatedly failed, while morale among American and Allied forces strengthened with every mile of restored track. The efficiency of repair operations became a force multiplier, enabling continuous pressure on German positions and contributing to the cumulative collapse of resistance across multiple theaters. The stage was set to examine the long-term consequences, how these repair operations reshaped strategy, doctrine, and the psychological landscape of both sides in the final months of the war. The battlefield, once defined solely by firepower, had revealed the decisive power of speed and ingenuity behind the lines. As 1945 progressed, the implications of rapid track repair became increasingly apparent. Allied armies maintained operational momentum across multiple theaters, while German forces struggled to adapt. Where previously the destruction of rail lines could buy days to regroup, it now often bought mere hours. This shift forced a reevaluation of German strategy, with commanders recognizing that infrastructure sabotage, once a reliable tool, was no longer decisive. In France, restored rail networks allowed the Allies to launch successive offensives with relentless continuity. Artillery barges could be resupplied without delay, armored units advanced with predictable support, and infantry divisions remained provisioned even under harsh winter conditions. The cumulative effect was strategic dominance. Operational pauses that might have given the Germans breathing room were eliminated. Allied commanders credited engineering units with sustaining the tempo of warfare, a factor that directly influenced the outcome of late war campaigns, including the push across the Rhine. German morale suffered in parallel. Officers frequently noted in reports and post-war memoirs the demoralizing effect of watching American engineers rebuild what they had destroyed. Destruction had always been a means of asserting control, yet time and again, the Americans neutralized these efforts. The realization that logistical superiority could outweigh tactical ingenuity created a sense of helplessness among German units. Frontline soldiers, facing the dual pressure of advancing Allied forces and unbroken supply chains, became increasingly strained. Strategically, the speed and efficiency of American repairs forced the Wehrmacht to divert resources previously dedicated to combat. Demolition units, engineers, and reconnaissance teams were reassigned in attempts to slow the flow of supplies. Yet these efforts were largely futile. Allied innovation, modular track panels, portable cranes, and coordinated repair protocols outpaced German disruption tactics. What had been a temporary defensive measure now required disproportionate effort from the Germans, further straining already stretched forces. The Allies' logistical success also influenced broader planning and doctrine. Military leaders increasingly recognized that victory relied not only on frontline combat, but on the unseen infrastructure that enabled movement and supply. Engineering units were integrated into operational planning from the outset, given strategic priority and supported with dedicated equipment and reinforcements. Rail repair became more than maintenance. It became a decisive instrument in warfare, shaping timelines, operational flexibility, and even psychological impact. These long-term consequences extended beyond the immediate battlefield. The speed of repair contributed to shortening campaigns, reducing prolonged attrition, and preserving the initiative for Allied forces. Cities and ports recovered functionality quickly, allowing for efficient distribution of supplies and reinforcements across multiple fronts. Engineers who rebuilt rail lines under fire were celebrated not just for technical skill, but for their direct influence on strategic outcomes. Their work demonstrated that operational success depended on more than combat power. It depended on the invisible hands that kept the war machine moving. German officers, reflecting after the war, consistently highlighted the psychological weight of these operations. Diaries, intelligence summaries, and post-war analyses describe repeated astonishment. Trains moved, supplies arrived, and fronts remained intact despite deliberate attempts to destroy infrastructure. The perception of invincibility surrounding American logistics created doubt and hesitation, influencing German tactical decisions long before engagements occurred. In this sense, rapid track repair was both a physical and psychological weapon. By the spring of 1945, the consequences were undeniable. Allied forces advanced with near-constant supply, executing coordinated offensives that German forces could no longer reliably counter. Infrastructure destruction, once a strategic lever, had lost its potency. The combination of technological innovation, human endurance, and precise leadership had fundamentally altered the conduct of war, demonstrating that speed and efficiency could rival even the most formidable armies in determining outcomes. The legacy of these operations would shape military thought for decades. Engineers who restored destroyed rails under fire proved that mobility, supply, and innovation could be as decisive as tanks and artillery. The astonishment of German officers became a historical testament. In modern mechanized warfare, logistics could determine victory, and rapid repair could rewrite the battlefield itself. The image lingers. Engineers, hands numb from frost, eyes focused, welding sparks glinting in the fading light, while German officers watch in silent disbelief. These men were not on the front lines firing weapons, yet their work shaped the course of battles, the tempo of campaigns, and the fate of armies. In the war of steel and speed, they proved that logistics could be as decisive as firepower. Rapid track repair revealed a fundamental truth of modern mechanized warfare. Victory depended not only on weapons, but on the ability to sustain them. A destroyed bridge or twisted rail could delay an advance for hours or days, but the Americans had compressed that time, turning disruption into opportunity. Each repaired mile represented human endurance, technological innovation, and strategic foresight acting in unison. For the Germans, witnessing this efficiency challenged assumptions about warfare itself. They had anticipated that destruction would slow the Allies, buying time to regroup or counterattack. Instead, they confronted a foe whose organization, ingenuity, and relentless pace neutralized obstacles before they could be exploited. The astonishment documented in diaries and intelligence reports underscores a simple yet profound lesson. In war, unseen hands can carry as much weight as visible force. Beyond the battlefield, these operations offer a timeless reflection on human ingenuity. They demonstrate how foresight, coordination, and technical skill can amplify impact, how quiet, disciplined labor can shape the course of history. The restored rails were more than metal and timber. They were arteries of survival, movement, and hope, enabling soldiers to fight, civilians to endure, and campaigns to succeed. Ultimately, the story of rapid track repair is a reminder that war is not only fought in explosions and gunfire, but in the precise, tireless, and often invisible work that sustains it. The engineer's achievement resonates as a testament to human determination, industrial capacity, and the power of preparation. In the end, the battlefield is as much a test of intellect and organization as it is of courage and weaponry. And sometimes, speed alone can redefine the outcome of history.